Hey there, this is a response to your video, Jamus28. My last name is pronounced Jacobian, so yeah, thanks for trying though, I appreciate it. You have two coils there. So as you can see, you have your coils right there, and I might as well just point them out. So there we go. Okay, so you have two coils there. Alright, what I would recommend is, if you're going to be paralleling these two, then I would definitely recommend having a timer. So just one of those, I don't know if you've seen those shed timers where you just turn um, it's like a countdown. Pools have these for their jets, for the jacuzzis, and rental houses, public storage places have them. It's just a timer. I would recommend running a timer because you're melting metal and you're drawing a massive amount of current. It's not a good idea under almost any circumstance to let that go unattended. I know I have timers. Um, so, because you're going to be pulling about 2,000 watts, but I'm going to assume that you know basic electrical theory there, so you don't overheat your conductors. Some tips and tricks that will help you. You have perlite. You actually have the same perlite that I bought from Home Depot. Same bag, looks the same. Really cool. This is what you want to do. If you want to have more control over the way you mix your cement, you have your furnace cement. Mine's the black stuff. I forgot off the top of my head. It comes in these caulk tubes, and I mixed it with the perlite. So, little tip about the perlite. If you get yourself some turkey baking pans, where those thick aluminum turkey baking pans, and get some nails, like maybe 1/4 inch, 3/8 of an inch nails, and what you want to do is poke holes in the bottom of these turkey basting pans, and you want to get like 3 of them. And in one bottom, you want to poke holes, or maybe like a roast beef kind of, with the raised sides. You're going to be using these as sieves. And the reason you don't want to run loose perlite, you don't want to just mix your loose perlite in with the furnace cement. You want to have gradations because you want to control the granularity of the perlite. You want to make sure that where you need high strength, you have the smallest, most fine-grained perlite, and where you want the most insulation, then you have the big, giant perlite. And the way you do that is you sieve them, so you put holes in all the 3/8 of an inch holes, like just shower the bottom of one of the biggest pans, and then you go through steps. So you pour the perlite in, and it's like prospecting basically. You just you let them go through, and then you have your store those in a cup. You have your biggest ones, and then in the next smaller selection size, you would use like maybe a 1/4 inch. So use like a 1/4 inch nail and poke holes, and do the same thing. And so you do your selection. That's why the video of my living room at the time was so messy, because I had just been sorting the perlite. So when you're done with that, the last size, I would say like 1/8 of an inch nail, like small nail. And that's going to take the longest because you want the finest perlite. And you want to go through this because ultimately it's going to help you. It's going to help you. It depends on how much control you want over the process, but I wanted complete control, so because I wanted to have structural stability in some parts, and for the part I'm about to mention that's coming up, you want structural stability in some parts of the furnace, and you want in some layers, like the tighter innermost layers, you want the most structural stability. But when you go outwards, so like here, alright, so basically, as an example, you want more insulation and less stability. There's a trade-off. So what you want to do is, where you have your stainless steel crucible here, so this is what you're going to have to do. You replace that crucible shape. You want to replace this shape with cardboard. So you want to get yourself some shipping cardboard, doesn't really matter, but you want it to be like tight, right? So you want this cardboard inner cylinder, and yes, you're going to be getting rid of the cardboard after you're done, but you want to basically have cardboard on the inside. You feel free to use hot glue. That's what I used to make this inner card. So you're going to make an inner cardboard shape. And the reason you're going to be doing this is because when you, I don't want to say fortify, you're basically going to be, so there's two, unless you have other materials, there's two additional pieces of, you need to get your inner cardboard shape, right? And you need to fill it in. And then you're going to cake, is the wrong word, but first word that comes to mind, you're going to cake the outside. You're going to basically build from the outside in, and then at the right time you're going to turn on the elements and they're going to burn the cardboard from the inside out, and you're going to clean that. So you're basically going to get rid of the inner filler. That's kind of like a concrete form in a way. So yeah, you're going to need like the key to doing this properly is you really want to get that cardboard, you want to make sure those windings are really, really nice and tight. You want to get that cardboard right up against those windings, and you want to make sure that the consistency of the perlite to the furnace cement, you want to make sure that your consistency is 3 parts of perlite to 1 part furnace cement. And that's with the smallest perlite. That's why you're sorting it, so you have the most stability, because when the pieces of perlite are small, you can control where it goes, and you can control it's stronger. Now, I did half. I did 2 parts perlite to 2 parts 50-50 of the furnace cement when I was mixing for the inner core, because I wanted strength. So less perlite, more refractivity, it's a good idea to have. So you basically want to have less perlite in the core and then more perlite, like 3-to-1 as you go out. And how far out should you go? Okay, that's where your bigger granules will help. So you're basically going to go like, let's see if I can aim this right. You're going to go like 2 inches out. So you're not even going to need to go as far out as you thought with that helium cylinder. You're not even going to need that. But what you will need is you're going to need those steel construction ties. If you've ever seen rebar tied, you know how they tie rebar with that steel wire, like mild steel wire. I wouldn't go to the lengths of getting stainless steel, it's just not worth it, but you can get just rebar wire, and you're going to use it for what it sounds like you're going to use it for. You're basically going to have like a small, maybe 1/4 inch layer out there. You're going to have a 1/4 inch layer on the outside, and these are stainless steel tubes, as you've discovered. These are stainless steel tubes. You're going to have that tie wire on the outside, and then you're like right up against it. So there's a cardboard form, and then there's the tie wire going around. It's like your reinforcement, right? Reinforcement for the cement. So it's going to be like almost serve the role of tie wire, like rebar almost for your furnace. So you're going to get some of that tie wire, and you're going to wind it around, and then you're going to use the smallest granules you've sorted from the perlite and mix it together 50-50, 1 part of each with the furnace cement, and make sure it's nice and dense. You want the consistency to be very dense. You can add a little bit of water, but you don't want to make it. You want it to be like putty or Play-Doh. So when you stick it on, it just like it sticks. It doesn't go anywhere. That will change as you go into the outer layers, but so you're going to do that, and then you're going to tie the construction tie wire. God, it's been a long day. The rebar tie wire, mild steel wire around. So once you do all that, that's probably going to take about a few days for all of that to cure, because furnace cement takes forever to cure, unless you have like some, I don't know, how did I do it? How did I keep it warm? I think I used a blower. Yeah, I used a blower, like a heat gun blower, and I had it on some masonry. So there's like this 300-degree stream of air coming in, like cooling it, heating it and getting the water out, because there will be a lot of water. And one of the issues is you want to slowly heat these elements up, because if it heats up too quickly, the water in the furnace cement will explode. So anyway, so yeah, so you want to do that, but you're on the right track. For the bed, remember when I said you're going to sort the granules of perlite? Right, so see, for the bottom of the furnace, you want to have a layer that's composed 3-to-1, 3 perlite, 1 furnace cement. You want that to be composed of the the biggest granules you have because they're the most insulating. They produce the biggest gaps in between the conducting, heat-conducting furnace cement. So for the inner core, you want a higher density of furnace cement. For the outer core, you want less furnace cement, more perlite, and then like 2.5 inches out, you can just start mixing the perlite with like normal cement. You don't need to mix it with furnace cement. But that's 2.5 inches out. With the 3-to-1 mixture, after the furnace cement has had a chance to insulate, then you can just mix it with like an outer shell of cement with perlite, and you can do like 50-50 there to regain your stability. So, but yeah, that's, is there anything I missed? No, that's about it. So, yeah, oh, and for the top, actually, when you're doing an electrical resistance furnace, don't vent it. You want to vent it for other reasons, but you're not going to be, you actually don't want oxygen to get in. One thing I learned is when oxygen gets in, it can actually, you want your metal to be non-exposed to oxygen. You don't want to expose it, non-oxidized. You don't want to expose it to oxygen. So, no, you'll be fine. The biggest trouble you're going to have is fabricating a way to lift up your crucible and perhaps fabricating like thermal feet on the bottom, so you're not actually, because as it stands right there, it looks like your coil goes all the way up to the very top of the crucible, and you actually want to have like maybe 1/2 inch of purchase so you can grasp with the steel tongs so you can lift it up. But yeah, it's the refractory that's going to give this its melting powers, and you want to make sure that the biggest secret to getting this right is this first step with the cardboard. You want this cardboard to be right up against, because when you cake that refractory on, the worst thing in the world that could happen is the refractory getting in, like getting in and obstructing the coil, and then after it dries, you have to go in there and you have to make sure that it's not obstructing that, and that's also important because you want basically you want it to, it refracts the heat. You want it to reflect it inward, so you want to make sure the coil's inner surfaces are all exposed very clearly. So, but you're on the right track. Hopefully this has helped out. 12 American wire gauge is the thinnest conducting supply wire you want to use. Use plenty of bolts and nuts, and I look forward to what you do with it. So, thanks for your question, and looking good.